Okay, we are recording. So we are this is introduction to trigonometry. Tyrone, you want to go ahead and read? You can go ahead.
Sure. Liam is 6 feet tall. To find the height of a tree, he measures his shadow and the tree's shadow. The measurements of the two shadows are shown. Find all of the missing measurements. Is it possible to figure out the missing angle measurements?
All right, so let's start out with just seeing, all right, we know that these two triangles are similar. They are similar because I told you that they are. And what can I start by doing to figure out a missing side length? Is there an equation I can set up? Is there a proportion I can set up? What can I do? Come on, guys, we've talked about these types of things for 2 weeks now. Everybody should absolutely know how to set up a proportion. So we could look for the scale factor. Matter of fact, let me back up a little bit. Let me label these sides so we can actually talk about them. I'll call this A, I'll call this one B, and this one C. How do I find the length of one of these? Which one can I start by looking for? Okay, Janelli says B. Now, how do I find the length of B? Okay, now here's my question to everybody. Is Perla the only person who paid attention the last 2 weeks? Because I don't think she is. I think everybody here knows how to do this. I don't understand why we're just waiting on Perla to answer every question. Because that's not fair. That's not fair. So let's start this again. We have two similar triangles. I can set up a proportion. This is baby math, y'all. This is something we've been doing for many, many days now. I should not have any difficulty with setting up a proportion. Like Perla said, my proportion can be 28 over 8 equals B over 6. Now we go ahead, what do I do now?
Cross multiply.
Cross multiply. What's 28 times 6? 168 divided by 8.
21.
What was that?
21.
21. So B is 21. So we got one
I
of
did
them.
mine's a different way, but still got 21.
How'd you do it?
I just divided 28 and 8.
Yeah, that works.
28 divided by 8.
Yeah, you can totally do it that way. So you did 3.5 and then you multiplied that by 6?
Yes.
Yeah, that's just a different way to do the same exact thing. Okay, so we got 21. Now, how can I find the other values? Now we could do, so if I do 21 over 6, what would the other side of this be? Okay, so if we're trying, because what are we still missing? Let's ask ourselves, what are we missing? A and C. We're still missing A as well as C. And if I want to use proportions, if I want to set up a proportion, what would the other side of this equation look like? Because I'm trying to find A and C. Well, if I write 28 over 8, is that helping me in any way to solve and find those missing sides? No, right? So what would I have to write on the other side? I would have to write 21 over 6 equals C over A. But can I solve that equation? There's two variables in it. Can you solve an equation that has two different variables in it? No. So proportions aren't going to help us out. Is there a different way though? I have right triangles. So is there a different way to figure out the length of the hypotenuse? What type of triangles do I have?
Right triangles.
Right triangles. What is a special property or a special theorem of right triangles that can help me figure out the length of the hypotenuse? It's not HL. That HL doesn't help me solve anything. There's a special equation for right triangles. I'm just going to sit here and wait till someone, oh, okay, there it is. What's that called?
Isn't that something like pi something? So would it be?
Pi what? Yeah.
Pythagorean theorem?
Yeah.
What it is?
Yeah, it's exactly what it is. Pythagorean theorem. I've said this because the first time we saw the Pythagorean theorem, it was like October. It never goes away. The Pythagorean theorem will be there forever for you guys. Like it'll come back over and over and over again. But anytime you see a right triangle, you should automatically think about the Pythagorean theorem because it helps us to find missing sides, and that's really important to be able to do. So let's do the Pythagorean theorem for the small triangle. What am I filling in to my equation? So what's the A, what's the B, what's the C?
Does it have to be in a specific order?
Only one of those has a specific place. Anyone? Not quite, nope. So I guess we got to review the Pythagorean theorem. Okay, did not expect to have to do that, but here we go. C squared, that has to be, this must be the hypotenuse. Must be the hypotenuse. A and B can be whichever of the two legs you want them to be. That doesn't matter, but C has to be the hypotenuse. So my equation has to be 8 squared plus 6 squared, or you could write 6 squared plus 8 squared. That part doesn't matter. The only part that matters is that C has to be A squared, the missing side. Okay, so go ahead, figure out what is the value of A. Once you get the value of A, then figure out what is the value of C. I'll give you guys about 3 minutes. 3 minutes to do that. All right, so you got 10 for A. 10 for A. All right, let's check. So 8 squared, oops. 8 squared is 64. This is 36. 64 plus 36 is 100. And what did you have to do in that last step, Janelle's? Square root. Good. You take the square root of both sides, and the square root of 10, of course, or the square root of 100, of course, is 10. So A equals 10. All right, we've got A. How do I find C now? How do I find C? Now that I have A, how do I find C? Yeah, since our scale factor is 3.5, we already determined that we can simply multiply times 3.5. So what will C be? What's 3.5 times 10? 35. Good. Okay, so we found all of the missing side lengths. Is it possible, there's a question down at the bottom, is it possible to figure out the missing angle measurements? Because right now, I do not know what the measurements are. I know that they're congruent since I have similar triangles. I know that I have congruent angles, but I don't know how much they measure. So is it possible to figure that out? Yeah, no, there isn't, unfortunately, until today. We don't know yet. You guys don't know yet how to do that, but by the end of, maybe not today, but definitely tomorrow, we will find a way to do so. So that's kind of where trigonometry is really, really useful, because trigonometry isn't that much about the side lengths. Trigonometry is a little bit more important as far as figuring out angle measurements and the properties of angles. So far, all we knew how to do is find side lengths with right triangles, but our knowledge kind of stops there. So let's broaden that knowledge a little bit. Okay, I'm gonna fill in, now that we have all these values, let me fill them in. What was this one? 21. Okay, what I want you guys to do is just go ahead and figure out the ratio, okay, the fraction of each of these different combinations. And I want you guys, once you get an answer, you can annotate it onto the screen. So just calculate what is, oh, and I didn't label them, hold on. A, B, C, and D, E, F. Go ahead and using those measurements, get all of those ratios, all of those fractions. Okay, in case anybody's confused, because I am waiting for annotations, but in case anybody's confused, I can do the first one. I'm doing AB over BC. So that would be 10 over 6. 10 over 6 equals 5/3. So I want you guys to go ahead, annotate the screen, fill in each of those fractions. What are they going to be? If I don't get any annotations in the next 10 seconds, I will be, thank you, Janelle's. I was going to say, I will be calling on people and assigning each of you a different one to do. And please reduce it to the smallest fraction. So if you're able to simplify it, then simplify it. Yes, give me 1 second, Tyrone. Okay, keep going. Okay, so we got 5/3, we got 5/4. Keep it going, guys. I see Janelle's is working on the screen. I see Jalen and I see Tyrone. Where's everyone else at? Okay, Janelle's and Perla. Okay. Okay, Tyrone, just do it. Just go do it.
For real, bro. I'm waiting.
We're all waiting on you. Daniel, do the last one. Daniel, do EF and FD.
I was doing that one, but okay.
Oh, I'm sorry. You already did one. Daniel, let's go.
Um,
10, 9,
I don't know.
8, 7, 6, 5, 4, 3, 2, 1. 6/8, what does that simplify to?
3/4.
3/4. The one Daniel failed to do, 21/28. What does that simplify to?
7/. Well, no. 3/4.
Also 3/4. Okay. So 3/4, 3/4, 5/4, 5/4, 5/3,
I'm stupid.
5/3. What's the pattern? They're all the same for every row, right? So the reason that they're the same is because take a look at what we're doing. In the first one, I did the hypotenuse over the shorter leg, the shorter leg. In the second one, I also did the hypotenuse over the shorter leg. So it was the same measurements were being put into a ratio. In the second row, now I'm doing AB over CA, so that's AB is the hypotenuse again, but this time over the longer leg. Same thing with the other triangle, DE over DF, or FD. Hypotenuse over the longer leg. And then in the last one, I was doing BC over CA, so that was shorter leg over longer leg. And same thing with the other triangle, shorter leg over longer leg. And since we have similar triangles, all of those ratios end up being the same, which is something that is going to be extremely, extremely important to understand when we move on to the next slide. So do I have any questions on that? Okay. So I was saying hypotenuse, shorter leg, longer leg, all of those different things, but there's actually words for these sides that we were comparing. So right now I would like you guys to go ahead and I'm going to highlight, and I want you guys to write down. We already know what a hypotenuse is, but it's always good to continue writing that down and making sure we keep that in our minds. So we've got the hypotenuse side. We have the opposite side. And we have the adjacent side. So please start by just writing down these definitions and copying down the 3 triangles and labeling it. And this is going to become extremely important for today, tomorrow, Friday, and next week as well. Because opposite and adjacent, we need to understand the difference between those 2 words and what they mean. So the opposite side is always the side that is across from an angle. So in this example, BC is opposite of angle A. And then when we're talking about adjacent sides, that's a side that is kind of directly next to an angle, but not the hypotenuse. So we've got hypotenuse, opposite sides, and adjacent sides. Take about 3 minutes to copy all of this down into your notebook. About 30 seconds left. All right, does anybody still need any time to copy down what's on this slide? One person? Wait, Perla, is that a yes, I need more time, or a no, I don't need more time? Okay, so we're good. Okay, cool. So again, these vocabulary words, they're gonna come back over and over again. So we're gonna just make sure to understand which side is the opposite side and which one is the adjacent side, because now we are going to learn something completely new. You've never learned it before, probably never seen it before. Maybe you've seen the buttons on your calculator, but you, before today, have never known what these are. So can I get a volunteer to read basically what's on this slide? The ratios, what's going on here? Who can read this short little statement?
Just the first sentence.
Mm-hmm.
The ratios of the side of a right triangle are called trigonometry ratios.
Okay. So we have these three ratios, which we actually already have calculated in this slide over here. We actually got those answers already. You just didn't know what they were called. So there's three ratios that we are going to be talking about and understanding today. And those are called the sine, cosine, and tangent. Sine, cosine, and tangent. And each of those ratios basically puts together two different sides from the triangle. It's just that each ratio puts them in a different order. And the way to remember this, because yeah, I know that this is all new and kind of weird. The way to remember this is there's kind of a little mnemonic device called SOHCAHTOA. So I'm going to write it down. SOHCAHTOA. Now I want you guys to copy that down as well. And actually, just go ahead and copy down all of this. These are our trigonometric ratios. Trigonometric ratios. So SOHCAHTOA is a way to remember which ratio is which sides. So SOH, SOHCAHTOA. So stands for sine, and the sine is the opposite over the hypotenuse. C stands for cosine. Cosine is adjacent over hypotenuse. And then TOA is for tangent, which is opposite over adjacent. So go ahead and write down SOHCAHTOA as well as what each of those ratios is. So tangent is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Now, as you finish writing this, I'm just going to look over at the diagram and just make sure that we see what's going on here. What we're doing is we're looking at the sine of angle A. So angle A is right here. So when I calculate the sine of A, I'm looking at the opposite angle, whatever that side length measures. So it's opposite over hypotenuse. So that's where the opposite side is. Cosine is adjacent. So it's next to angle A, adjacent over hypotenuse. And then the tangent of A is the opposite over the adjacent. So that's why those words are really important, to just make sure you remember which one's opposite, which one is adjacent, and which one is the hypotenuse. Because in a moment, we're going to do this using numbers. So does anybody still need a couple seconds to write this down? Yes? Okay, that's fine. All right, anybody else need a second? Okay. So here's an actual example. Here's a triangle. We've got some numbers. We've got our SOHCAHTOA. Let's label the sides. So let's start by just labeling each side so that we remember which one is which. So if angle A is the one we're looking at, which side is the opposite side of angle A? Which one's my opposite? Good, CB, yeah. Yeah, you're good. CB, that's my opposite, because it's the one across, all the way across from A. So that's my opposite. Okay, which side is the hypotenuse? Good. AB is the hypotenuse. And you can always find the hypotenuse because it's the longest side, and also because it's always across, it's always opposite from the 90-degree angle, the right angle. So that's my hypotenuse, which leaves the adjacent side. My adjacent side is AC. Okay, so I've got my three sides labeled. Now let's go ahead and calculate. This is now where it gets kind of easy, because now you're just going to plug in the numbers and find your answers. So what is the sine of A? What numbers go into that ratio? Three over five, good. 3 over 5. What is the cosine of A? Good, 4 over 5. And then the tangent of A? 3/4. Awesome. So see, it's not like hard to do, it's just new vocabulary and new concepts to learn about, okay? So don't be too freaked out if this looks confusing, because really we're just doing the same thing we've been doing, we just have different names for them. Yeah, it makes it look hard, it's really not that hard. Just new names, new vocabulary. It always seems overwhelming, but it's really not. Any questions so far on sine and cosine and tangent? We'll do another example. Does anyone still need a moment to copy down? Okay, so next one. Here's SOHCAHTOA, just to continue to remember what each of those means. So now we're looking for the sine of F. Okay, so I'm gonna go to F, and let's always start by labeling which side is which. So where is the opposite side? Which one is my opposite? Okay, so it's not 5, it's what Perla said, it's DE, it's 12. Because remember, opposite's located always across from your angle. So look across. So that's my opposite side. Okay, which one is the hypotenuse? Good, 13. And then finally, we have the adjacent side. And remember, adjacent means next to. So notice how that DF is right next to angle F. So that's why that one's the adjacent side. Okay, sine. What is the ratio for sine? It's which side over which side? So what's in the numerator? Good. Opposite over hypotenuse. And that's why SOHCAHTOA is so easy and helpful to remember. So this is opposite over hypotenuse. Okay, so in this case, the sine of F would be what? Good, 12 over 13. All right, cosine. Cosine is what over what? Okay, nope, that's not cosine. So SOHCAHTOA. Adjacent over hypotenuse, good. Okay, so in this case, what's that going to be? Good, 5 over 13. And then finally, tangent, good, Emily, opposite over adjacent. Okay, and in this case, what's that? 12 over 5, good. Awesome, awesome, okay. Kind of getting the hang of it, right? Like I said, the biggest struggle is just remembering which side is which and what sine is, what's cosine, and what's tangent. So we're just gonna work hard today on making sure we remember what those three things are. How do we feel? Any questions up to this point? Good. Now, question for you guys. If I was looking for the sine of E, would I be putting in the same numbers in that case? Good. It wouldn't be the same because E is a completely different angle from F. So if I'm looking for the sine of E, I would have to go back and start over and label my sides again because the opposite angle for E is different than the opposite angle for F. The hypotenuse is the only one that stays the same, but basically the opposite angle would be the angle that was adjacent for F, and then the adjacent angle would be the angle that was opposite for F. So things switch around depending on which angle you're actually looking from. Okay, let's do one more. I want you guys to try this on your own. So I'll copy down SOHCAHTOA just to keep it there for you guys. And go ahead and try this on your own. Figure out what is sine of G, cosine of G, and tangent of G. Okay, about a minute remaining. All right. All right. Which side is my opposite side? Which one's my opposite? Good, Janelle's got all three. So opposite side is 15. Hypotenuse is 17. And adjacent is my 8. Okay, perfect. So now sine. Sine of G, what's that one going to be? Sine of G. 15 over 17. Good. This is opposite over adjacent. So we get, or sorry, opposite over hypotenuse, my bad. So this is going to be 15 over 17. How about cosine of G? Cosine of G. 8 over 17. Good. Here I'm doing adjacent over hypotenuse. So that's 8 over 17. And then tangent of G. 15 over 8. Good. This is opposite over adjacent. So we got 15 over 8. Perfect. So here's my 3 ratios. Can I get a volunteer to read the bottom statement? We have a little bit of a question to think about. Who can read for us? Oh, Tyrone, go ahead.
Suppose triangle GHI undergoes a dilation with a scale factor of 3 to create triangle GHI prime. Will the sine, cosine, and tangent of angle G prime compare to that of angle G?
So how will that compare? Will it be the same? Will it be different? Will we have to multiply? What do you guys think?
I think like the fraction won't be the same, but it'll end up simplifying to the same thing.
Right. So it at the end should simplify to be the same. Now, why is that? Why would it be the same?
Because all you're doing is like making it 3 times bigger. You're not changing anything else about it, and dilations preserve angle measures.
There it
They
is.
create proportional sides, so you shouldn't have an issue with that.
There it is. So you said the magic words. Dilations preserve angle measurements. So remember, if I dilate this, angle G prime is still congruent to angle G. They're the same. So the sine of G and the sine of G prime should be the same because the value of G has not changed at all. So even if the side lengths increase, so let's actually look at what would happen. So if I actually did it and I dilated it by a factor of 3, okay, this would be 45. 8 times 3 is 24, and 17 times 3 is 51. Let's just look at what would happen to the sine of G prime? What would be the two numbers that go into the sine of G prime? Good, 45 over 51. 45 over 51. Well, 45 and 51 are both divisible by 3. So when you simplify 45 divided by 3 and 51 divided by 3, we end up with 15 over 17. We got the same exact value. And that just goes to show, since dilations preserve angle measurements, sine, cosine, and tangent is going to be exactly the same for similar triangles. So if you know that the two triangles are similar, then the sine is going to be the same, the cosine is going to be the same, and the tangent is going to be the same for both triangles. Any questions on that? Awesome. All right. Okay, so let's take a look at this triangle. We're not doing anything that much different quite yet, but just take a look at this triangle, triangle CAT, and we're going to calculate the sine and the cosine of angle C and angle T. So let's start with angle C. If I'm highlighting, let me highlight angle C. Which one's the opposite? Which one's my opposite side? AT, good. So here's my opposite. Which one's my adjacent side? 7. And my hypotenuse is, of course, CT. Okay. The sine of C. Sine of C. What numbers go into sine of C? Look at SOHCAHTOA. Sine is what over what? Matter of fact, I'm gonna call names because I've been hearing from the same two people. I want to make sure everybody's understanding. So Rios, sine of C, what am I plugging in to find the sine of C? You got 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. No answer. Well, privately answered, but you don't have any final answers, Rios? No? Okay. Daniel, what am I plugging in for the sine of C?
Six.
Hmm?
7.
Just 7?
7.5. I don't.
The sine of C. How did I just spend 15, 20 minutes teaching this and my students don't know how to do it? Okay, Daniel, nope. Tyrone, what's the sine of C? Nope, incorrect. Who else is here? Eric, Sine of C. Eric, I can't hear you. I can't see you. Type it in the chat. You got 10 seconds. Sine of C. Nope. Samaj, sine of C. Ten seconds, Samaj. What is the sine of C? Nope. Emily, sine of C. Put it on public, please. (24 over 25).
Oh shoot, I'm dumb. It says it at the top.
Yeah, it does, Daniel. It really does. But it's not just you. It was 7 out of 9 students, 6 out of 9 students, and that's a big problem. That's telling me that y'all were not paying attention one bit. So what's about to happen, because Ms. Lopez does not appreciate when her students just sit there and stare at the screen, is there is an assignment. Let me add, hold on. If you've been paying attention, you should not be worried at all right now. You should be just fine. Everybody right now, go to Khan Academy and look for, I'll write it on the screen, look for the assignment. I already put it up. It's called Trigonometric Ratios in Right Triangles. Trigonometric ratios in right triangles. Go on Khan Academy right now. Look for that assignment. Everybody at this time has the remaining time. There's 15 minutes left. You have 15 minutes to complete that assignment. If it's not done, it's an automatic F in the grade book. If you just sit there and you don't do it, automatic F. You have 15 minutes. Complete the assignment by 2:20, and it will be counting for a quiz grade. Your time starts now. Now you can do it more than once. You can do it more than once if you do poorly the first time.